Unfortunately, AI is again being hyped very, very strong. Business Week, one of the magazines in US, actually had the front cover in 1984, I believe. It says AI, it's finally here. People get all excited and create hype cycles. AI machines are essentially child machines. You train them just like you train your children, that's supervised learning. Then you test them. 7 to 8% of US economy easily runs on COBOL. And most of the US Army, Department of Defense runs on COBOL. So some of the nuclear submarines run on COBOL.
GPT-4o is like a Ferrari for grocery shopping.
McKinsey says it's about $15 trillion will come out of it by 2030. Everyone talks about China and US. People are forgetting that India has the largest number of software professionals right now in the world. Metaverse probably will occur more like 15 to 20 years from now. AI is not machine learning, and machine learning is not AI.
Hello, everyone. My pleasure to welcome all of you at the new episode for the new episode of Prime Podcast. The guest I have today is someone that I've been really looking forward to chat with. He's an engineer and computer scientist. He spent 15 plus years with IBM and did deep research at the intersection of computer science, operations, and data analytics. He holds 9 patents and several research publications. He was also the founding director of IBM Research's India office, which he helped set up at IIT Delhi, his alma mater. He later went on to found Evalueserve, a professional services company that provides research and analytics services in intellectual property, legal processes, market and business research, and data analytics. It went on to become a global company with offices and research centers in 15 plus countries. In his most recent role, he's contributing meaningfully in AI by founding Scry AI, which provides AI-based product solutions and services in BFSI, technology and heavy engineering, and life sciences and healthcare industries. He's currently running the company as the CEO. To top all of that, he recently authored a book, Demystifying AI, called Fourth Industrial Revolution and 100 Years of AI from 1950 to 2050. Dr. Alok, it's my pleasure to welcome you, and I'm glad that we are doing this conversation.
Thank you for having me.
Great. So to kick this conversation off right off the bat, Dr. Alok, I'm reading your book, and what kind of I found very interesting is that you mentioned that AI has brought about the fourth industrial revolution, and with the past 3 kind of triggered by the discovery of steam engines, electrical motor, and most recently CPUs. So what are the characteristics of the industrial revolution, and why do you think AI has the potential or is actually in the midst of drawing out a fourth one? What is so fundamentally different about AI than the previous revolutions?
So every revolution, industrial revolution, has its distinctness. The interesting part when I started writing the book is I did not realize that nobody had really defined what an industrial revolution was. So actually the first chapter sets up a framework for industrial revolutions and what are their characteristics. How do we know that this is the fourth revolution, not the fifth one or the third one, and so on and so forth. So from that perspective, the first chapter actually sets up 8 characteristics of all industrial revolutions that I have seen. And I'm not saying by any means that these are all the characteristics. There may be more that I have not discussed or I do not even know about. The first one, typically in each industrial revolution, has been that it wasn't formed by one invention. It was formed by several inventions, and they actually often used each other to improve. So an inventor or inventors would use one invention to improve another, and so on. So the first, for example, as you said, the main invention was the steam engine, which was being used almost throughout, and it became pervasive and very well known. So water and steam infrastructure was created. And what steam was obviously needed for steam engines, steam also started as an infrastructure, water and steam also started fueling flour mills, for example, converting wheat to flour, textile mills, and so on. So the first characteristic of all these inventions is that there are several inventions. I'll come to other revolutions in a minute. The second is that it at least creates one infrastructure for the society. In the first revolution, it was water and steam infrastructure. In the second one, it was because of electricity or electric motors, electric generation and dissemination or distribution was the infrastructure. And interestingly, electricity not only propelled or fueled electric motors, but also electric bulbs and many other things which have nothing to do with motors. The third infrastructure again had several inventions, but the one which became the infrastructure going forward was electronic communication, wireless, Wi-Fi, and so on. Before that, 1995, most of us were using dialing, using basically phone lines to dial from home to the office, which was extremely slow. And that basically fundamentally changed that. So those are the first three. And the third characteristic is that there is one invention which basically becomes pervasive during the entire period, and it becomes ubiquitous. For example, steam engines began to be used pretty much everywhere in the 1800s, all the way from steam trains or railroads to steamboats, steamships, and so on. Second one, electric motors. There are about 3,500 different types of electric motors. They're being used everywhere. In my room sitting here, I'm sure there are at least 6 or 8 electric motors running in the fan, in the air conditioning unit, and so on. And then there are five other characteristics which we can go through in more detail. But going back to your question, this particular industrial revolution has many inventions. So not only AI and inventions related to data, but also inventions related to climate change, related to Internet of Things, robotics, gene editing, personalized healthcare, blockchain, metaverse, AR, VR. Not that all of these will happen immediately. In fact, most of these revolutions were there for 40 to 80 years. So we started here in 2011 for the fourth industrial revolution. Probably it will continue till 2050, if not 2060. And some of these inventions, like metaverse, probably will occur more like 15 to 20 years from now, because we don't even have the high order broadband communication or wireless 6G wireless communication. But we can discuss the other 5 as we go along. Why AI is different is that each of these inventions in each revolution, which became pervasive, was markedly different than the previous one. For example, steam generators or steam engines were working very differently than motors. And it moved from effectively what I would call resource-based infrastructure, which is the resource was water or steam, to an electricity-based infrastructure, which was created by humans. Electricity was being generated by humans. The third infrastructure was quite different from the second, because the infrastructure was that in communication, and there was nothing being generated, so to speak. It was just being communicated from one end to the other. And the fourth infrastructure with AI, it's now about data, which we can say it's very much like electricity or like steam engines, steam or water, or like broadband, but data has many, many facets, and it's very much different. So although people say data is the new oil or data is the new electricity, they're actually obfuscating a lot of the issues or a lot of the important points that data has. And AI is, of course, using data to be the next pervasive invention. We already have, people do not realize often, already have more than 2,500 use cases of AI which are operational in nature. Everyone today is hyped up about LLMs and GPTs, but actually there are many, many instances where AI is already being used and will be used by 2050. My belief is at least in 100,000 use cases.
AI by design what you can say, a lot more intelligent than the previous three, right? It has a lot more capabilities around, reasoning, about contextual understanding, about vision understanding, and basis which it can enable, as you said, right, multiple of these use cases, right? So do you think because of that, and for example, many of the big tech leaders, whether it's Sundar Pichai came out with the statement, right, that invention of AI is as instrumental, if not more, than electricity, right? Than the invention of electricity, right? Now that's a big statement, arguably, that there are vested interests and so on and so forth, right? But do you kind of believe that the acceleration, or the unlock of use cases through AI could be a lot more pervasive than what the previous ones have been? Or do you think, it's too early to kind of really figure that out? Because AI has this fundamentally, I would say, meaningful intelligence over the past three, right? So do you think it would affect how it gets kind of seeped into the mainstream?
Yes, two aspects. One is that unfortunately AI is again being hyped very, very strongly, partly by various technology companies, partly by the media. This is not the first time that this hype has happened. In fact, when artificial intelligence was initially created by Alan Turing by talking about the imitation game, after that there was a conference in 1956 in Dartmouth College, and that's when the name was given. And during 1956 to 1973, AI was hyped equally strongly, maybe more, maybe a bit less, but about the same in many ways. In fact, a movie was created, 2001: A Space Odyssey, in which the computer HAL 9000 is considered to be an artificial general intelligence computer with emotions, abilities to scheme, arrogance, all the human characteristics, and much more. And he can beat people in chess and so on. So from that perspective, that was the first hype. It went sour, it went bust in 1973. The second hype started in 1980 with expert systems. And that's a very important thing. What is AI? AI, in effect, is a combination of machine learning and expert systems being knowledge base, be subject matter expertise. And even for humans, without subject matter expertise, we are not able to do most of the work. We become eventually knowledge workers in some field or the other, or are doing basic work like typing and so on. So from that perspective, 1980s, again, there was a hype. It was short-lived. It went bust in 1987, 88. And then this is now again the hype. Interestingly, all hype cycles have the same thing. Business Week, one of the magazines in US, actually had the front cover in 1984, I believe. It says, AI, it's finally here. And isn't that almost what everyone is saying, including Mr. Pichai and others? AI, it's finally here. Having said that, all inventions, that is the fourth characteristic I bring out of industrial revolutions. All industrial revolutions have these very important inventions, but they take time to seep into the society. Things did not happen overnight. For example, railroads, the first railroad was created in 1830 between Liverpool and Manchester, and people got so excited. Obviously, steam engines were getting pervasive. People got so excited. Inventors, investors, and then the public, media, they all put in a lot of money. By 1890, it was oversaturated. The hype had died down. Most of the railroads went bust. Same thing we see in the during the second industrial revolution with telegraphs, in the third industrial revolution with telecoms and dot-com booms. I mean, the telecom money, about $500 billion was spent in, billion, not million, 500 billion was spent in to lay cables in sea, underwater, that is, under soil, the wireless, Wi-Fi, and many of these companies went bust. So it takes time for inventions to seep into the society. And of course, the time is reducing, but it is not going away. For example, In 1882, the first electric generation plant was created by Thomas Alva Edison in upstate New York. That was in 1882, but it was only in 1925, that is about 43 years later, that half of Americans got electricity. So 43 years later. Similarly, even more recently, the first handheld phone was created in Motorola by Cooper in 1971. But it was only in 1990s that people actually started using handheld phones. I'm just talking about not even smartphones like BlackBerry or
Yeah.
So that is something which is very important to keep in mind, that things take time to seep into society. And I give 8 reasons why that's the case. I mean, and everyone actually falls into that, including me. When I started Evalueserve, we gave the notion of knowledge process outsourcing. And we said in 11 years or 10 years, this is how much it will be, and India will gain so much out of it. The rest of the world will gain so much out of it. Not that fundamentally we were wrong about the time. It took at least 2 times what we had projected, what I had projected. And that is the 5th characteristic of industrial revolutions. 4th being things take time to seep into the society. 5th being that people get all excited and create hype cycles which go boom in the past. Of course, many of these hype cycles are good. I mean, if there was no hype cycle, we would probably have no railroads. Most of the railroads that we have today are because of the hype cycle that got created in England and in US. And that's a good thing. So I actually am a very strong believer. It may hurt the investors who may lose their shirt, but it helps the society in the long run. So definitely AI will play a big role, probably a bigger role than electricity, although that's hard to say at this point. But I think that will happen gradually. The pace will begin to pick up, but it will happen. As I said, we clearly have about 2,500 use cases that I know of, and I'm putting up about 1,000 of them by the end of August on our website. There may many more, and I think it will go to 100,000. So from that perspective, there are only 3,500 motors, electric motors of different kinds, but there may be about 100,000 different use cases or different type of AI systems. So from that perspective, Mr. Pichai may be right.
Excellent. I think that's a good segue to discuss what is the present state of AI, right? You mentioned about 2,500 use cases out there, and with your experience at Scry and the research for the book, what sectors and industries are you most excited about with respect to AI adoption, and maybe some examples of the use cases that are getting accelerated or maybe altogether replaced by AI first approach, if you want to pick your favorite out of those 1,000?
So first of all, I think pretty much all of the industries and departments of organizations, or you can say divisions of organizations, will be affected by AI. There is absolutely no doubt in my mind that if we look at the long trajectory, I mean, if we assume that the revolution started in fourth industrial revolution started in 2011 with IBM winning the Jeopardy contest. My feeling is we have at least another perhaps 10 to 15 more years to go before AI really seeps deeply into it. And so as part of those 1,000 use cases, pretty much, I would say, I've broken up into 19 industries, 1 government, the 20, and then 10 different departments or different divisions of a typical organization: finance and accounting, procurement, marketing and sales, and so on and so forth. So from a perspective of companies, you can look at AI. Ultimately, if we take out the hype, what can AI do today or in the near future? One thing it is very good as classifying. That is, it differentiates between the faces of dogs and cats. That's a very simple example in vision. But a more interesting example is to differentiate whether a person has skin cancer or a person should be given out a loan. So these are classification. Secondly, it is very good at figuring out patterns. So otherwise, AI, as Alan Turing said, AI machines are essentially child machines. You train them just like you train your children, that's supervised learning. Then you test them, and if the test fails, doesn't have enough accuracy, you train more, or you rewrite the AI program. So from that perspective, already there is a lot of innovation, lot of use cases in Internet of Things. For example, figuring out whether somebody has a water leakage or a gas leakage in his or her house. Or there is about 4% water around the world gets leaked in water pipes as the water companies send the water for the purified water, the potable water from their plants to homes. So a lot of this is getting now, because the sensors are relatively inexpensive, that a lot of this is happening already and will continue to happen in the area of supply chain management and in general Internet of Things. Clearly, that would be one of the big fields, if I would call a vertical, which will get affected. Another one will be banking and finance, insurance. Now, insurance has a very interesting problem because, especially life insurance, because it goes on for 40, 50 years, and therefore they have so much data which is in paper-based data, and that paper is not the facts of today, very, very poor quality. So converting, no matter even humans cannot understand it, forget about AI understanding it. So that's a very important problem, and I think it will be resolved in the next 10 to 12 years. Another problem, which is along the same lines, is reverse engineering of COBOL programs. So COBOL was a language which was created in 1960-61. And even though it's a very simple language, because it's a simple language, people never wrote documentation regarding it. And even today, about 7 to 8% of US economy easily runs on COBOL. So all of insurance companies today. I mean, India fortunately got saved because COBOL by 1980s had become already an older language, and newer languages had come in, Java and so on, C++, C, Java. But COBOL for the Western world, for the more developed world, is a very, very big problem because people like me, I mean, I learned COBOL in IT in 1975, one course when we did not have even tapes. We had deck of cards, which we used to feed into the computers. And I mean, people like me, pretty much most of them have retired. Some even unfortunately passed away. There is no documentation. And what happened is, like happens all the time, is that people modify their COBOL programs, and those have bugs in them. Nobody can now figure out where are the bugs. So just to give you an idea, most of the US Army Department of Defense runs on COBOL. So some of the nuclear submarines run on COBOL. So that's another area which I personally think where AI will actually help in basically reverse engineering COBOL programs, so that you don't need, effectively, you need very few, if any, COBOL programmers. The other advantage of reverse engineering of COBOL program using AI is because it doesn't know the syntax of COBOL. It would actually find all the errors or most of the errors that are in the COBOL program, because it's not transliterating COBOL program into a Python or a Java program, but into a flowchart. So then there are many use cases which are very interesting. I mean, healthcare is another one which will be fundamentally changed in the next 10 to 14 years. But again, the hype is far exceeds what reality is, which is the sad part. And right now, I mean, on the other hand, as I write in the book, hype is good, because if we put in $50 billion in LLMs and GPTs, it is good for the human society, because something good would come out. Problems are hard problems. They're not easy problems. So you need a lot of people, you need a lot of money.
Yeah. Interesting. And I think that's a good segue to the next set of topics that I had in mind, right? I mean, given that you're serving large industries of all, shapes and sizes, right? First with Evalueserve, now with Scry, where are these companies in the AI journey, right? Because what we constantly hear is that lot of pilot testing is going on, but barely anything has moved into production, right? Sequoia came out with a recent report that, a lot of capex is being spent, but in enabling generative AI, in powering LLMs, but there's not a commensurate revenue to kind of make up for that, right? Uh, Google, Meta, Microsoft, all these guys, I think they recently had their quarterly earnings, and all of them are spending anywhere from 15 to $20 billion every year, every quarter, not every year, every quarter, as capex. A large chunk of that is obviously going in procuring the GPUs. Obviously, Nvidia is obviously Nvidia stock has been touching the skies, but none of that has resulted into the kind of revenue, right? Or maybe the production use cases, right? So what do you hear from your customers, right? I mean, where are they in the journey, right? Among the use cases which are kind of already proven. Yeah.
Yeah. So again, I go back to the characteristics of the Industrial Revolution. I said the fourth characteristic was that it takes time for even the best inventions to seep into the society. The fifth being that people get hyped up about it, and therefore you have a boom bust cycle. And we are in a very strong boom bust cycle because the problem is everyone has gotten excited about one very, very specific aspect of AI, which is GPTs and LLMs, large language models and generative pre-trained transformer. The first paper in this regard came from Google Research itself. It was a research paper called "Attention is All You Need," and after that, Google created BERT, which was the first transformer. It wasn't that good because it didn't have enough parameters, so to speak, without going into details. But since then, the race or the war began. LLMs are very interesting for humans because it can write me a recommendation letter. It can summarize very large pieces of text for me. It can improve my English. They've been trained. These particular deep learning models or deep learning networks are trained on anywhere from 400 million pages to a billion pages of text and tables and so on. So they're very, very good in writing English. They're almost perfect in writing English. Imagine a kid going through that many novels. If a novel is about 400 pages long, that's a large novel, maybe 200 pages long, talking about 2 million novels. Then either the kid will go crazy, but also the kid will probably become excellent in writing English, very cogent, very proficient. And that's what you see in LLMs also. They're extremely cogent, they're extremely proficient, they're so good that they can even fool lawyers, and they have fooled lawyers into believing that non-existing cases exist. So just like I was talking about the kid, that the kid will go crazy and will become proficient. Probably that's what's happening. We don't know what's happening with machine learning models, but probably that's what is happening with machine learning models. They're both crazy, and that's why they hallucinate, and they are extremely good in writing, which is actually in a very interesting way or a sad way for humans, because they're writing so well, we trust them, and that's what we call machine endearment, but then they hallucinate. So we haven't really found out actually good ways of using these particular deep learning networks called large language models and GPTs in real sense of the word. Yes, it can write a very good poem for me. It can elaborate something for me. It can write a story, but can I use it in any meaningful manner? And I think this is what Sequoia is talking about. I think this is what also Goldman Sachs is talking about. This is what I write in chapter 11 of the book. Not that they will not be used. Again, goes back to the Industrial Revolution and its characteristics. 10 years down the road, they will be commonplace. We would have figured out. But right now, we don't even have the first, second, third mile problem, several mile problems solved for these GPTs. For example, they're trained on internet data, but a company has its own data, which is paper-based, PDF-based, Excel spreadsheets, and so on. So the first mile is you have to convert all this data so that a large language model can ingest. So those are the ones why I think Sequoia, I think there was also a small comment or a small article from Barclays. Sequoia and Goldman Sachs have been on the forefront. in December 2023, when I wrote the book in chapter 11, I said, look, it's more hype than reality because McKinsey says it's about $15 trillion will come out of it by 2030, or it'll affect $15 trillion. Now, the world's GDP will be only 150 trillion. So you're talking about it affecting 10% of the economy of the world. I don't think that's even going to be close to where we are. Having said that, there are many areas which we don't even, today we don't even see where AI is. For example, so many, not so many, but many airports, including in the US, have started using face recognition to speed up the immigration process. So in Dubai, if you go, it's your face that it checks, and if it's 98% correct, it'll just let you go. Literally, it reduces your time from 10 minutes to 10 seconds. Singapore has done the same. US government, slightly more cautious, does it all for specific people that it has already screened in the past, called global services people, travel services people. So we don't even talk about these things. Very soon, a lot of these, the biometric recognition, whether it's pupils, face recognition, hands, in many countries, not in the US or Europe, but in many other countries, will be used as a way to check out of a grocery store. Not in the US because US is still worried about privacy, and so is particularly Europe. Similarly, if you look in agriculture, there is a lot going on in agriculture in trying to understand various aspects, how much nitrogen is there, how do I implant seeds in the dirt without literally opening up the dirt. Because the moment you open up the dirt, which has been for the last 3,000 years or maybe 5,000 years, that you basically use an animal which has machine, a small machine in the sense it has a small tool in it which will open the dirt, and then you throw seeds. And that always gets carbon dioxide into the air, that always loses moisture into the air, and above all, it loses topsoil to the seeds. So a lot is happening in agriculture, and agriculture, I believe, in 25 years will fundamentally change. So there are areas where things are moving and moving very rapidly. One area which I'm particularly interested in, and particularly because of Scry, is intelligent document processing. There is so much paper and PDF documents, but these are either unstructured or semi-structured in nature. You need to convert it into an electronic form to be able to automatically use AI to play with it, to give decisions, support, and so on. But unless you can get that completely resolved with very little human intervention, you will not be able to solve this problem. And that, out of the 1,000 use cases, there are about 120 use cases on intelligent document processing alone, what all it can do or should be able to do. And some of them are already, in some form or the other, are already being implemented. The simplest one is OC.
Got it. So, so our audience has, a large chunk of our audience are founders, who are already building or kind of thinking of building a business, right? So what areas within AI, right, do you think a new entrant can contribute to and in the process build a large business, right? I mean, what should they keep in mind while serving incumbents, right? And
I would suggest they look into three areas very particularly. And particularly because generally the entrepreneurs are technologists, they miss out on these areas quite a bit. One is to make sure that you start small with a small problem. But the area, effectively, that there are many adjacencies. So I'll start with the use case, but there are many use cases which are very close by, and I can solve them in the long run. Now, that doesn't mean I will solve them on day one. It may take a 7-year journey, 5-year journey. And by the way, I mean, unless you're, as an entrepreneur, unless you're planning on selling the company for 100 million or 50 million, most companies take 20 to 25 years really to build. So you should keep deciding as to which particular direction you want to go. whether you're in it for about half of your working life, or you're in it for or one third of your working life, or only for 5 years of it. Both are perfectly fine. I'm not advocating one versus another, but that's something which is very important. Having said that, that they should keep adjacencies in mind. That look, I'm going to look at this use case to make a minimum viable product, but then I'll go and expand it because those are the use cases I can expand to. Second thing that they should be very careful about is AI is not machine learning, and machine learning is not AI. There is no equivalence between. AI is a superset of machine learning. And as I said, the second AI boom and bust happened because of expert systems. So no matter how much we put in, even in LLMs and GPTs, how much we train them, 400 million pages, 500 billion words, they still require context. They still require, and humans too, by the way, also. I mean, I'm not into accounting. Somebody comes to me and says, can you figure out what is the total operating income of a bank? Here is the report. And suppose that number is not given, I may not know what are the formulas I will use because I don't have the context. And obviously, AI suffers a lot from that. I mean, GPTs and LLMs, child will suffer a lot, even a human will suffer a lot. So I think it is very important for them to understand the distinction between machine learning and say, look, I need to add actually knowledge matter into it, subject matter expertise. So that is a very, very fundamental thing. My own view is, and I live in Silicon Valley, and my own view is 90% of companies, startups will fail because they do not include the subject matter expertise into the entire story. The third is not to get caught up with the hype. A lot of people are just taking either open source LLM models or just open source models, putting them together and creating a minimum viable product out. Great, you can do something, you can create a chatbot out of it, and so on and so forth. And if you're a services company, it may all work out also because you'll move on to the next project. But if you're a product company, then you don't have any intellectual property associated. So, I mean, how do you sell? I'll give you an example of intelligent document processing. Which basically takes the data, which is scanned data or PDF data, converts it into electronic data. But unlike humans, which have two eyes, the machine converts it into literally in one dimension. So it loses the context of tables, loses the context of graphs, charts, etc. So you have the second problem, which is to recreate tables with pretty much 100% accuracy, graphs and charts. And then suppose I come and tell you that, look, it's 90% correct. You're my client. Your immediate reaction is, okay, that's pretty good. It's 90% correct, but this is a 300-page document you just converted. Will I have to review it from left to right for all the 300 pages because I know where the 10% is wrong, right? So the question is, if I can reconcile, for example, various things. Suppose there is a table in it, which is income statement. I can reconcile and I can show you that, look, or not me, but the AI software says, look, in this statement, A plus B plus C should equal D. And indeed, the numbers are A plus B plus C equals D. Then you don't have to review it. So I can very, very clearly point out which are the issues, where are the issues, and so on and so forth. This is just one example that you add, because everyone, there are 57 or 58 companies that we know of. There may be more companies in intelligent document processing, but none of them everyone will say, oh, you will need a human in the loop. Not clear that you will need a human in the loop. In humans, yes, we have a maker and a checker, but it's not that we use checker all the time because checker is expensive. It's our two eyes which solve the problem. With my right eye closed, I look at you and I say it's Pankaj. With my left eye closed, I look at you and say Pankaj. The error of my being wrong is squared, because if my right eye was 90% correct, error was 10%. My left eye was 90% correct, error was 10%. And if both eyes were working independent of each other, the error becomes squared. That is only 1% wrong. 10% wrong there, 10%. So what I'm trying to say is there are interesting areas that people can go into. Now, I'm not saying everyone will, but I'm saying that in product business, you have to have intellectual property that you can defend. And unfortunately, I do not see that right now. I mean, this is one of the things where people are rushing. It's more than a gold rush. I call it a platinum or a diamond rush. That people are not rushing to figure out what the issues are and how to solve the problem.
Could data be that intellectual property? So one common theme, or rather the playbook, and I wrote about it on LinkedIn recently, that a playbook is, as you said, right, identify a painful enough use case, build a superior product to solve that. That becomes your sort of foot in the door product, generate demand, bring along customers doing that. In the process, hopefully you are generating some high quality and proprietary data, which you can use to kind of keep on making the product better. So do you think the data itself could be that IP?
I don't think data will be the IP. I think use of the right data is part of the residual knowledge, right?
Correct.
And that is where subject matter expertise comes in. So what data will I use? Because there is a lot of data around, but a lot of data is also noisy and you can't use it.
So, yeah, that's what I mean. Quality of data, not just data.
Quality of data is, but yeah. So that goes back to subject matter expertise. What data do I use? How do I get to creating a product which is superior? And when I say superior, it has intellectual property which is hard for people to overcome. The sad part about AI is, or in general software is, yeah, you can write patents, but they are worth not even the paper they're written on. You give me a patent in software, in AI, because it's math, eventually, I can go around it fairly easy. It's not like building a company. And I know you folks are in the venture capital business, and I know many VCs who get all excited about patents. Even though we could probably in our company write about 30 to 40 patents, we have not written a single one, because we know the moment we write a patent, we have essentially given our intellectual property away. Somebody will just go around it and figure out.
Yeah, makes sense.
It's like what reconciliation of intelligent document processing. We have not written a single patent on how do we reconcile. How does the system learn formulas which are there in a PDF document automatically? Or how does the formulas get learned in COBOL program?
And I think rightly so, right? Another theme which I agree with that you pointed out, that subject matter expertise will be relevant, right? So if you see now Llama came up with 405 billion parameters, and it is kind of giving a chase to GPT 4.0, right? And a lot of experts are kind of saying that GPT 4.0 is like a Ferrari for grocery shopping, right? It's just too over the top for most of the things, right? Versus open source model that you can access, you can utilize, you can train on your specific use case, make it like work really, really well and accurately for that domain. So that will be the future, and that's where subject matter expertise becomes more and more kind of relevant. I personally feel that models themselves are probably the fastest depreciating asset in history, probably, right?
In some sense, they're not even depreciating, right? Because they become open source very quickly. Like Llama is open source. I mean, Mixtral is open source. I can choose a bunch of open source models and then I can put them together. Now, what is intellectual property is Llama has, let's say, in a particular metric, 90% accuracy, Mixtral has 88%, and all of these are open source. Can I now put them together in a meaningful way so that my accuracy becomes 92% in the whole process? So that becomes my intellectual property. Now, if I put subject matter expertise on top of it, then I can get to 95, 96%. And then if I can reconcile everything and show you that there is no hallucination, because I'm showing you where the particular thing got its answer from, then you are a happy person as a client, right? I mean, then that you say, look, you have really saved me time, money, cost, etc., and above all, human labor. So I think these things will take time. They always, and that's why chapter 1 of the book is so important, because it sets up a framework that, look, let's not get carried away. I mean, and it's perfectly fine if we get carried away also, because I do say that hype, booms, bust cycles are actually good for society. I mean, we saw that with driverless cars recently, about $100 billion was spent in there. And yeah, some amount of it really went into research, and eventually we will solve the driverless car problem. It may be eventually, maybe 10 to 15 years from now. So I'm not even saying that hype cycles are bad cycles for the human society. They are actually probably good things to have. But
Got
about
it.
investors and inventors, of course, they lose their shirt, so they feel bad.
Yeah, yeah.
So that's it.
No, this has been super interesting. I have one last question that I've been kind of trying to unpack for last couple of months, right? As I go deeper into AI, right? So I think AI, with its power to either as a co-pilot or kind of make the overall system more efficient, has the ability to kind of add meaningful value in services businesses, right? And there is an emerging concept that rather than software as a service, there could be certain areas where service as a software has the right characteristics of a venture scale business, right? Producing venture scale business in terms of capital efficient growth, velocity of growth, and so on and so forth, right? Given that you have experience in both now, right, with Evalueserve, with respect to KPO, and now with Scry, you are kind of building AI products for these customers, large customers. What is your view? I mean, if you were to, let's say, think of starting Evalueserve in today's world, would you do anything differently? You mentioned that it took you twice the time you projected to get to the scale, right? Do you think that would be faster, or where do you think, how should an investor think about the services space generally, and how can it be powered by AI?
Actually, after writing the book, I decided this year to convert two things: to convert the book into 36 lectures of 45 minutes each, because not everyone reads books these days. Very few people read books, and by no means the book is small. It's actually 270 pages of fairly dense material. It's not intense because it doesn't have math or computer science, but it is dense.
Yeah.
You have to think about it, read it once more before it begins to seep into your into the brain, into your thought process. So that's one, and the second is to write at least 8 articles on India and AI, because everyone talks about China and US. People are forgetting that India has the largest number of software professionals right now in the world. And
13 million developers out of 30 million, yeah.
So, and that is 5.5 million software developers actually working on a day-to-day basis in all these companies. So, and we're not talking about HTML and CSS developers, we're talking about software engineering developers. Yeah, I mean, the world has about 25 million and India has about 5.4. So people forget about that. And that is going to be a very, very important aspect about India's growth in AI, which people don't realize. Having said that, so my first first article was the unsung heroes of AI, how data annotation will grow enormously, meteorically in India. The second one was, of course, loneliness in India will rise because of AI. The third one is that the services industry in AI will be transformed radically by AI in the next 10 years. Because you talked about Evalueserve, and I think about Evalueserve all the time, because I'm still invested in it fairly heavily, even though I'm not on the board. And if I were to redo it, I would just completely redo it with software first and humans later. And about 50% of the work that Evalueserve does, and to me, about 70% of the work that TCS and others do, especially in the BPO domain, like Genpact, like EXL service, 70% of the work is within the next 3 to 5 years can be reduced by a factor of 2. So, which is a lot, right? Because suddenly if the clients begin to realize that you've reduced it by a factor of 2, they'll say, why are you charging me X when you should be charging me X over 2? And then you say, okay, there is a software cost, they'll still pay you maybe 0.6, 0.7 times that. So everyone gains in the whole process. And this,
and plus it can also expand the overall demand, right? The Jevons paradox will kick in. You reduce the cost of technology per unit consumption, the demand will grow up. Yeah.
Absolutely, because second one is it will go pay by the drink, not by the FTE, so to speak. So you will go into, as you rightly said, small, medium-sized businesses who cannot afford an EXL or an Evalueserve today will be able to afford the next generation of companies. So I think this is going to be a very, very fundamental change. The only good news and this paper should come out in September. The only good news I see is that it is not going to happen in the next 3 years. It may take 7 to 10 years for this change to occur. But this change is imminent. This change is, I hope TCS, Infosys, etc., are waking up to this change. It's not that these people will go away, but you will still have 50%. You'll have people will go upstream and so on. And India may actually gain a lot. It is an opportunity for India to really play very strongly in the industrial revolution because the foundation is set, because India has so many software engineers, because India can produce enormous number of data annotators who can check for ground truth, who can do data annotation, who can tell you that, look, this part is this portion, because in supervised learning, we need data annotation.
Yeah. Fantastic. So thanks a lot. Really, really appreciated doing this conversation. Of course, we'll recommend the audience to check out your book. We'll link it in the show notes. And thanks for taking the time to chat with us.
Thank you, Pankaj. Thank you so much. And thanks, Jerome, for making it work, all of it. Thanks.
I'll write to you separately, sir. I'll take your details from Jerome. I would love for you to talk to Empirical, and at some point in time, of course, we would want him to spend some time in the US. So, of course, would love for you guys to, he's from your alma mater. So and your alma mater building something in AI. So I think 2 strong reasons for you to, take the time out and have a chat. And I think it will be helpful for him as well.
Yeah, sure. Absolutely.
Yeah. All right. Have a great day, sir. Thank you.
Thank you. Bye.
Bye.
Dear listeners, thank you for listening to this episode of the podcast. Subscribe now on your favorite podcast app for free, and you'll be the first one to know when new episodes are available. Just search for Prime Venture Partners Podcast in Apple Podcast, Spotify, Castbox, or however you get your podcasts. Then hit subscribe. And if you have enjoyed the show, we would be really grateful if you leave us a review on Apple Podcast. To read the full transcript, find the link in the show notes.